Hello, I'm Gabriela Ragusa, and today I will be giving a presentation on the drug Remdesivir. If you watch the news frequently or keep up with the progress and research from the global pandemic due to coronavirus, you may have read about or heard talk of the FDA-approved drug Remdesivir. So what exactly is Remdesivir? Well, it's an antiviral drug used to treat patients who suffer from COVID-19. I'll give a brief background on the drug real quick, which is something that I found to be very interesting when conducting my research. So Remdesivir has been in the clinical setting for over a decade now, since around 2009. It was originally developed to treat hepatitis C and RSV with no success. After the Ebola outbreak a few years ago, it was also treated against that disease with very little success. However, researchers knew that they were in the right direction, and they didn't give up. After running tests on various animals, humans, cells, anything you can imagine, studies showed that Remdesivir did seem to be effective in treating severe acute respiratory syndrome, or SARS. After the coronavirus outbreak, Remdesivir did end up being a suitable drug for the illness and became the first FDA-approved COVID-19 drug in 2020, nearly over a year ago. So Remdesivir is administered intravenously over a 5 to 15 day period, and you must be 12 years old and 88 pounds to receive the drug. While this drug has been proven to be effective, not everyone is a candidate. You won't walk into a pharmacy and find it on the shelf. Remdesivir can only be administered in the hospital setting, and relatively everyone who is hospitalized from COVID is administered Remdesivir. So why did I choose this drug? For this presentation, I had the option of choosing between various drugs, toxins, diseases, pretty much anything that you can imagine. However, I knew that I wanted to do my research on something relevant, something that could be of use to anyone, and something that nearly everyone would find interesting. What better to research than the drug that has saved and improved the lives of so many? COVID-19 has run our lives for nearly 2 years. It has taken so much away from each and every one of us, family, friends, loved ones. COVID-19 has completely turned our lives around. I was originally going to do my presentation on SARS-CoV-2 virus, but as I began preparing my research, I became disinterested because of all of the negatives that I was coming across in various articles and journals. Then a thought came to me. Why not do my presentation on a drug that saves and improves lives, instead of the one that takes away lives? Although Remdesivir is not an end-all be-all, it does give us some hope that there may be light at the end of the tunnel. There are over 5 million reported COVID-19 related deaths. Just take a minute and let that sink in. 5 million people have died at the hands of one single virus. Those who have been administered Remdesivir seem to recover quicker than those who do not receive Remdesivir. On average, recovery times seem to improve by 5 days faster than those who don't receive the drug. If this drug can do anything at all to improve the lives of the poor sick patients stuck in the cold hospital rooms, alone, wondering if they'll ever see their families again, then it should be considered useful. Any step in the right direction is a victory worth celebrating. I'd also like to point out that the first clinical trial was launched in the United States. This is pretty interesting that our country can be accredited with that. Okay, as I've already stated, Remdesivir is to treat COVID-19, which is an acute respiratory disease. And then from the drug, there are side effects, as there are with any medication, vaccine, drug, headache, nausea, itching, lightheadedness, just to name a few. Then I wanted to add this visual of the signs and symptoms associated with COVID-19, which we're probably all very familiar with. How effective is Remdesivir? Well, we only have about a year's worth of data to view when determining the effectiveness of it. So far, everything has been positive, and pretty much all researchers can agree that the antiviral treatment is beneficial to most everyone. Now, you'll see here that I have an 89% survival rate. I'll put an asterisk by this bullet point. Obviously, not everyone who receives Remdesivir is going to survive COVID-19. Underlying health issues, age, respiratory issues. Those are just a few issues that are common causes of mortality in coronavirus patients. Those who receive supplemental oxygen, those who are put on a ventilator, they have smaller chances of survival. Doctors never claim that Remdesivir is a cure. They just claimed it to improve the severity of symptoms, leading to quicker recovery time. Remdesivir works best on mild to severe cases of COVID-19. So how do we know that Remdesivir is effective? So there's three aspects of the clinical trial that the researchers measured. The recovery rates, which seem to increase, faster rates. The severity of the disease, so the symptoms seem to decrease, and the mortality rates, which seem to also decrease. So how they measured that, they gave certain number of people the drug, and then they gave others a placebo, which was likely like a sugar pill or something to give the illusion that they were receiving the drug to cancel out any factors that may have impaired doctor or patient effects of the drug, and everything seemed to score in the right direction in Remdesivir's favor, which leads it to be, that's how we know that it seems to be effective. So, how does Remdesivir work? First off, it's a prodrug. Now, you probably are asking, what's a prodrug? So, a prodrug is a biologically inactive compound that can be metabolized in the body to produce a drug. Then your body's metabolism converts the drug into its active form, which allows it to mimic the RNA in the virus. Therefore, new RNA is created, and the virus will be eventually terminated, which is something that I'll explain on the next slide. So basically, upon injection, Remdesivir is in its inactive form. When the active virus meets the inactive Remdesivir in the human body, it's converted into the active form. The active form of Remdesivir works to terminate or end RNA transcription. RNA transcriptions work to copy gene sequences to produce more RNA, known as messenger RNA. Remdesivir attempts to counteract the work that the coronavirus is trying to do by stopping the production of the virus. As we know, viruses can't survive without the host cell, and ultimately the virus will end up dying not long after Remdesivir is administered. Okay. Now, here's the tricky part. Remdesivir is an ATP analog, meaning that it competes with ATP for incorporation into RNA. So the nucleoside analog resembles a nitrogenous base. The nitrogenous bases are naturally occurring essential building blocks of DNA and RNA. So Remdesivir mimics the nucleoside analogs in the virus. The nucleoside analogs, which is what Remdesivir is, are genetically modified in the laboratory setting to mimic the genome sequence of the virus they want to terminate. So basically, Remdesivir has a very similar genome sequence to the virus. about one of the nucleoside analogs is different when comparing the virus to remdesivir. So remdesivir blocks RNA polymerase in coronavirus. RNA polymerase is a key enzyme that is essential for viral replication. The enzyme that chooses the nucleoside analog ever so often will grab the wrong nucleoside analog, being that's from the one from remdesivir, rather than the naturally occurring one from the virus, and incorporate the new genetically modified one into the new growing RNA strand. So once the body realizes that this new RNA strand does not contain the sequence needed to continue producing the virus, the result will end in termination of RNA transcription and decrease in viral reproduction. Okay, so viruses, how do they work? So they enter the cell and rely on the host cell to carry out replication. Basically, that's as simple as it gets. Here's a little bit of information about coronavirus that I'm not going to go through. Remember that remdesivir binds to the RNA-dependent RNA polymerase. Then that, once again, is the mechanism that the virus uses to make copies of itself. The anticipated end result is that remdesivir is incorporated into the new RNA strand. The genome sequence is altered, and it's now different than that of coronavirus, and the body will no longer be able to replicate the virus. There are 19 known strands of COVID-19, and remdesivir seems to be effective on all known strands. Now, I'm going to come back to this. Coronavirus is single-stranded. It's a class 4 animal virus, and class 4 animal viruses directly serve as messenger RNA and immediately translate that into the viral proteins. Here's a little visual. You can see the spike protein, the virus is enveloped, and okay. Regarding advancements in the field of biology due to the invention of remdesivir, here are a few points to remember. First, there are only around 30 approved antiviral drugs, give or take. Antivirals are relatively safe for the body. Some have been approved for children as young as 2 weeks old and pregnant women as well. This tells us that there are few worries associated with antivirals. The next point is that very few antiviral drugs have been known to be effective. So the fact that remdesivir seemed to work against coronavirus, we were pretty lucky that that worked in our favor, considering that nearly 3 in 1 Americans have been diagnosed with COVID-19. Just think of how many people that you know that have tested positive. Probably too many people to even begin to count. The virus is real, it's scary, and it's not going away. Remdesivir gives me a little peace of mind in knowing that there is something out there that may put us on the road to an easier recovery. Of all the scientists, researchers, and doctors of the past and present who have ever contributed to the understanding of RNA transcription and the understanding of viruses, should be credited with the progress of remdesivir and that all that it has offered us during these trying times. One last thing I would like to conclude before I conclude this presentation. Please remember that the job of remdesivir is to reduce viral loads. It's not a cure for coronavirus. Unfortunately, it won't save everyone's life, but above all, it's a therapeutic agent that works to reduce the severity of the disease and help patients recover quicker. We have all been affected by COVID-19 in many, many ways. In such a short period of time, our worlds have been turned completely upside down. It has taken away so much from each and every one of us, so many lives, so many lost opportunities. The frontline healthcare workers deserve all the praise and respect for their continuous hard work and advancements. Remdesivir has certainly improved mortality rates and decreased the length of hospital stays for COVID-19 patients, which gives me hope and peace of mind. Thank you for reviewing my presentation today, and I hope you all stay happy and healthy.